Bismillahirrahmanirrahim. Our next theorem, that negative of a linear transformation. Let T such that U tend to V be a linear transformation from the vector space U to the vector space V over the same field F. Then the mapping minus T defined as minus Tx is equal to minus Tx for x is an element of the vector space U over the field F is a linear transformation. Since the mapping minus T such that U tend to V is defined as minus Tx is equal to minus Tx according to the hypothesis for x is an element of the vector space U over the field F, and for any two element xy in the vector space U, AB are the element of the field, the linear combination AX plus BY is an element of the vector space U according to the condition of the vector space. That is, the linear combination of any two element of the vector space is again an element of the vector space, and therefore minus T AX plus BY. AX plus BY is the resultant element of the vector space U. When we apply minus T, the operator minus T according to this condition, which is equal to minus 1 multiplied by TAX plus BY according to our hypothesis, according to the given hypothesis. That is minus, and T is a linear operator according to the hypothesis. T is a linear operator. Therefore, when we apply T on AX plus BY, which will be equal to a TX plus B TY according to the condition, according to the definition of the linear operator or linear transformation, and multiply by minus 1 with each of these two terms. We have minus A multiplied by Tx minus B multiplied by Ty, or we can also rewrite it as A multiplied by minus Tx plus B multiplied by minus Ty. That is minus T Ax plus By is equal to minus A multiplied by minus Tx plus B multiplied by minus Ty. That is, minus T is a linear operator from the vector space U to the vector space V over the field F, over the same field F.